Hopefully we see the need for product rule that x times cosine y. There's a need for product rule there, and we see y is mixed into the equation. There's implicit. We see two y variables in the original equation. We should be expecting two dy dx to pop up. So now this completes the calculus process. The rest of it is, can we add and subtract and divide in a way where we can isolate that dy dx by itself? Divide the parentheses over. This is perfectly fine. But if this was multiple choice answer, they will probably multiply a negative through the top and the bottom and make everything positive. Okay. Number 5. Okay. Anytime we see trig with that exponent written in that way, right, we always want to spend time to rewrite it with a set of brackets. Sorry, velocity is given. Sorry, all this should be in terms of p here. Okay, so before we do our derivative, let's rewrite it. Outside's derivative, 6 bracket squared. Tangent's derivative is secant squared u times u prime. Now we can replace every t with power 4. Again, I think it's helpful if you're evaluating to put that exponent outside a set of parentheses. It's just easier to make sure we have our order of operations correct. Now we know that at power 4, our order pair is root 2 over 2 and root 2 over 2. Tangent is just going to be 1 because y over x, which is canceled out. Secant is the reciprocal of my cosine, which is my x value. So I just flip my cosine, and that will give me my secant. Okay, number 6, find tangent line equation. So plug in the power of 6 to get your order pair. Get the bracket to show up before you find the derivative. And then from there, you can find slope. The order pair at power 3 is 1/2 root 3 over 2. So we know secant is the reciprocal of cosine of the x value. So that'll just give us 2. Square that. We get 8. Right, next up, we can move into our derivative. We know chain rule will be involved once we get that bracket to show up. Now that we have outside derivative, we're going to take time with the inside derivative. In a separate space, secant of u becomes secant u tangent u times u prime. Pull all the coefficients out in front. Replace all the x's with 5 or 6. Which is really power of 3. So secant is the reciprocal of cosine. You know, if cosine is 1/2, then secant would be 2. And tangent is y over x, root 3 over 2 divided by 1/2. I can just cover up the 2's. I know the 2's cancel out. Just look at the numerator. I get y is root 3, x is 1, root 3 over 1 is just root 3. So 8 times 2 times 2, 32, root 3 is my slope. Okay. The point that I gathered from my function, power of 6 is the x value, 8 is the y value. All right, any questions here? All right, let's turn to worksheet 4. See if you can spend a minute writing down your 6 trig derivative rules, see how much you can recall. And start working through each of the problems. I've got the key attached, but I'll go through each of the problems with you as well. Okay, start there. Okay, first, we set up set of brackets, identify that outside inside portion that we need for chain rule. Power rule for the outside portion. Tangent u becomes secant squared u times u prime. And then as far as cleanup, just push combine all the non-trig terms in front. By number 2. Now, pretty much once you go through quotient rule, the only cleanup for this problem is just moving that e in front of the trig term, but you don't really have to do much in terms of cleanup. Just make sure all the pieces are there for quotient rule. Okay, so cotangent becomes negative cosecant squared u times u prime. G function stays, f function stays, and then g's derivative is secant u tangent u times u prime, all over g squared. Okay, number 3. You either recognize the Nees product rule for number 3. Okay, back page. All right, what do you see for number 4? Listen, yeah. How many dy dx's do we expect to show up? 4. Yeah, we have 4 y variables that we see. We should be expecting 4 dy dx's to pop up. Okay, what else? Product rule, yeah, that y cosine y. There's a need for product rule there. Okay, so what should we write down as a derivative for y? You guys put down. Yeah. If you just put UIDX, it's fine. You won't lose any points. It's just, it may cause some trouble. You may forget to remember that when you factor that UIDX out, there's still a 1 sitting there. So whenever I see y by itself, I like to put a 1 UIDX so that it's a visual reminder that when that UIDX gets factored out, I still have that 1 left over. We don't want to lose that placeholder for that term. This first term doesn't really matter. It's the fact that when y is by itself, we tend to forget that we still need something there when that variable is factored out. F prime g plus f g prime. After we find our derivative, we should be able to count and see that we have 4 separate dy dx's, and now we're just trying to add and subtract in a way where we can group them together on the same side. Then we can factor that dy dx out and then divide over. Question. Okay, once that dy dx gets factored out, we can divide the parentheses over, and there's our derivative. Okay, number 5, position function is provided. Find acceleration. So we have to make our way down 2 derivatives from position to velocity, and then from velocity to acceleration. Cotangent's derivative is negative cosecant squared x. Get that bracket to show up so that we can get ready for our next set of derivatives. To get from velocity to acceleration, we got to go through chain rule, outside, inside. Right. Negative 3 bracket squared becomes negative 6 bracket to the first power. That's my outside derivative. Cosecant's derivative is negative cosecant x, cotangent x times 1. Here's my cleaned up acceleration. And now my next step is plugging power 4 in for all the x's. Okay. Power 4 has an order pair root 2 over 2, root 2 over 2. Cosecant is just the reciprocal of the y value. Cotangent is just x over y. Okay, number 6. Tangent line equation. Get that bracket to show up first. And then we can see the need for chain rule. If you want, though, you can go ahead and find the order pair first. It's up to you which one you want to do first, but we have to plug pi over 6 in for x. 2 times pi over 6 is really pi over 3. We know that cotangent is x over y, so 1 over root 3. Clean that up. My order pair is 2 over 3 root 3. Root 3 cubed is just root 3 times root 3 times root 3. 2 of the root 3s will combine to be 3, and the other root 3 will stay, so 2 over 3 times root 3. Next up, derivative. Chain rule, 2 bracket cube becomes 6 bracket squared. Cotangent of u becomes negative cosecant squared u times u prime. Do some cleanup. Replace all the x's with pi over 6, which in turn will turn into pi over 3. And again, getting this down to numeric ratio values. And then it cleans up all the way to negative 16 over 3. Here's my slope. We gather the order pair already, and then put it all together, point slope form. Okay, so no homework, but I will check page 17 and worksheet 4. We did both of them in class, so if you followed along with what we did in class, we can also check those off at the beginning of class tomorrow. Help session tomorrow morning, 7:30. Help session Tuesday morning, 7:30 as well. I'll send out a reminder this afternoon. And then tomorrow we'll work on worksheet 5. Monday we'll work on worksheet 6. And next Tuesday is your quiz. No calculator. Okay. All right, come get your phones.